Draw a triangle. Any triangle. On a napkin, in the air with your finger, in your mind right now. 3 lines, 3 corners. Done. Now here is the thing that should stop you cold. That triangle obeys a rule. The 3 angles inside it add up to exactly 180 degrees. Not roughly, not approximately. Exactly. Every time. On every napkin, in every country, in every century, humans have been drawing triangles. You probably learned that rule in school and forgot it by lunch. But sit with it for a second. Nobody invented that rule. Euclid wrote it down around 300 BCE, but he did not make it up. He discovered it. The rule was already there, waiting, the same way a fossil is already in the rock before anyone digs it up. Humans just found it. So where was it before we found it? That is not a trick question. It is the question this whole video is built on. Because the deeper you go into mathematics and physics, the more you run into this feeling, this slightly unsettling suspicion that the universe was already running on geometry long before anything alive existed to notice. Long before eyes. Long before brains. Long before the first microbe floated in some shallow prehistoric ocean. The spiral of a galaxy and the spiral of a nautilus shell follow the same mathematical curve. The ratio of a bee's female ancestors to male ancestors traces the Fibonacci sequence. The path a planet takes around a star is an ellipse, and an ellipse is not a label we stuck on it. It is a precise geometric object with exact properties, and planets trace it because the mathematics of gravity demands it. The universe is not approximately geometric. It is not poetically geometric. The way people say a snowflake is geometric because it looks pretty and symmetrical. It is geometric in the way an equation is geometric. Precisely, necessarily, inescapably. And here is where it gets strange. For roughly 13.8 billion years, this geometry ran on its own. Galaxies spiraled. Black holes warped space-time into shapes that make Euclidean triangles look like child's play. Quantum particles interfered with each other in wave patterns so mathematically exact that engineers now build the chips inside your phone by exploiting them. All of it running on geometry. None of it watched. None of it known. Then, on a small wet rock orbiting an unremarkable star in a galaxy that contains 200 to 400 billion other stars, something happened. A brain formed that could do mathematics. Not instinctively, the way a bird navigates by magnetic fields. Not reflexively, the way a spider's legs know how to build a web. A brain that could sit down, invent symbols, and then use those symbols to reach out across billions of light years and correctly describe the shape of space-time around a black hole it has never visited and never will. That is what happened. That is what we are. We are, as far as we know, the first things in this universe to look at the geometry and understand it, to name it, to prove it, to feel something about it. And once you really absorb that, once you let that land, a question rises up that you cannot easily put back down. Did the geometry always exist, waiting for a mind to find it? Or did it need a mind to make it real? That question has a name. It has occupied philosophers and physicists for centuries. It is one of the deepest unsolved problems in the nature of reality, and we are going to follow it all the way to the edge. Start with something you can hold in your hand. A crystal of salt. The kind you shake onto food without thinking. Look at it under a microscope, and you see a cube. Not roughly a cube, a perfect cube. Because sodium and chloride ions stack at exactly 90 angles because of the electromagnetic forces between them. The geometry is not decoration. It is the structure. The physics demands the shape. Now zoom out slightly. DNA, the molecule that carries the instructions for building you, is a double helix. A helix is a precise geometric form. It is not that DNA happens to look like a spiral the way a river sometimes bends into a curve. The helix is the optimal shape for storing long strands of information in a compact, stable, readable way. Evolution did not plan that. Mathematics did. Evolution just selected for it because it worked. Every cell in your body contains about 2 meters of DNA. You have roughly 37 trillion cells. If you could lay all that DNA end to end, it would stretch from Earth to Pluto and back more than once. All of it in helices. All of it in geometry. Now zoom further out. Stand outside on a clear night and look up at the moon. The moon is about 384,000 kilometers away. Light covers that distance in just over 1 second. That 1 second gap is already hard to feel. You have never moved at the speed of light. So the number floats in your mind without weight. Here is how to give it weight. The fastest aircraft ever built by humans, the SR-71 Blackbird, flew at roughly 3,500 kilometers per hour. At that speed, reaching the moon would take about 4.5 days. You could leave on a Monday, arrive Friday morning, tired, stiff, the journey barely survivable in the psychological sense of staring at the same black void for 4.5 days straight. That is the moon, our nearest neighbor, the thing that fits behind your thumb when you hold it up at arm's length. Now go further. The sun is 150 million kilometers away. At Blackbird speed, you are looking at just under 5 years of flight. Light covers it in 8 minutes. 8 minutes of sunlight hitting your face right now left the sun before you finished your last meal, probably. It crossed 150 million kilometers of vacuum to land on your skin, and you were not thinking about that at all. Here is the gut punch. The nearest star to our sun, Proxima Centauri, is 4.24 light-years away. Not kilometers, light-years. 1 light-year is roughly 9.46 trillion kilometers. Multiply that by 4.24. At Blackbird speed, the fastest thing human hands have ever built for sustained flight, it would take you approximately 4.7 million years to reach the nearest star. We have been modern humans for about 300,000 years. We have been keeping written records for about 5,000. The nearest star is 4.7 million Blackbird years away, and Proxima Centauri is essentially our next-door neighbor. The Milky Way galaxy is about 100,000 light-years across. The nearest large galaxy, Andromeda, is 2.537 million light-years away. The observable universe, the sphere of space we can theoretically see from Earth, stretches 46 billion light-years in every direction. These numbers stop meaning anything if you just say them. So, try this. If you shrank the observable universe down to the size of Earth, the Milky Way would be smaller than a single atom. That is the ratio. That is the proportion. We are not small, in the way that an ant is small, compared to a human. We are small in a way that has no comfortable analogy, because nothing in ordinary human experience operates at these scales. And yet, the geometry runs through all of it. General relativity. Einstein's description of gravity describes the shape of space-time itself as a geometric object. A massive body like a star curves the fabric of space-time around it, the way a bowling ball curves a rubber sheet. Other objects then move along the curved geometry of that space-time. What we call gravity is not really a force being exerted. It is the geometry of space, telling matter which way to move. That is not a metaphor. That is the actual physics. Verified, tested. GPS satellites require corrections for relativistic time dilation. The fact that time runs slightly faster in orbit than on the surface, because the geometry of space-time is slightly less curved up there. Without those corrections, GPS would drift by about 11 kilometers per day. Your maps work because engineers applied Einstein's geometry. The universe is not just shaped by mathematics. It runs on it, actively, in real time. Now here is the thing that should make you stop breathing for a second. Quantum mechanics, the physics of the very small, describes particles not as tiny marbles but as wave functions. Mathematical objects. Probability distributions spread through space. When you measure a particle, the wave function collapses to a definite state. But until then, The particle exists as a superposition of possibilities, described entirely by an equation. The particle is, in some deep sense, a mathematical object first and a physical thing second. Roger Penrose, one of the greatest mathematical physicists alive, spent decades arguing that mathematical objects are not inventions of the human mind. They exist independently of minds. We discover them. He calls the mathematical world a real realm, as real as the physical and mental worlds, existing in a relationship with both that we do not yet fully understand. The other side of this argument, equally serious, equally unresolved, says mathematics is a human construction, a language we built to describe patterns we observe. The patterns are real. The language is ours. Here is what makes it impossible to settle. The mathematics we invent for purely abstract reasons with no application in mind, no physical experiment motivating it, keeps turning out to describe reality decades or centuries later. Riemannian geometry was developed in the 1850s as a pure mathematical exercise in curved spaces. It had no practical use. Einstein used it in 1915 to build general relativity. Complex numbers were invented as a mathematical trick in the 16th century. They turned out to be the language quantum mechanics runs on. Why would an invented language keep accidentally describing the universe? Either we are discovering something real, or the coincidences are so systematic and so profound that the word coincidence stops doing the work we need it to do. Which means the question is not just philosophical. It might be the most practical question of all. Are we minds that live in the universe? Or are we the place where the universe finally started to understand itself? Let's go back to the triangle. 3 lines, 3 angles, 180 degrees. That rule holds on Earth. It holds on the moon. It holds with a small correction for curved space-time near a black hole. It held before the first star ignited. It held in the first second after the Big Bang, when the universe was a hot, dense plasma, with no atoms yet, no molecules, no planets, no possibility of life. The geometry was already there. This is the fact that philosophers call the unreasonable effectiveness of mathematics, a phrase coined by the physicist Eugene Wigner in 1960. He was not being rhetorical. He was genuinely alarmed. He thought the fact that mathematics describes physical reality with such precision was a mystery that demanded explanation and had not received one. It still has not. Here is one way to sit with that. The universe is roughly 13.8 billion years old. Life on Earth has existed for about 3.8 billion years. Complex animals with nervous systems appeared maybe 600 million years ago. Modern humans arrived somewhere around 300,000 years ago. Written mathematics, humans deliberately encoding abstract numerical reasoning, is perhaps 5,000 years old. For 13.7999 billion years, the geometry ran in darkness. No one measured it, no one named it, no one proved it. Galaxies spiraled in their exact logarithmic curves with no one watching. Black holes bent space-time into shapes that would have taken human mathematicians centuries to describe. And there were no human mathematicians. And there was no description. And it happened anyway, because it had to, because the mathematics required it. And then, on this particular rock, in this particular window of cosmic time, neurons arranged themselves into a configuration that could ask, why does this work? Not just what is happening. Why does it happen this way, in these shapes, according to these rules? No other species we have found can ask that. No other planet we have visited shows signs of anything asking that. We are broadcasting into the silence, and the silence is answering back with silence. For all the evidence we have, we are alone in our noticing. Think about what that means. The universe spent 13.8 billion years writing a proof. Every galaxy, every spiral, every quantum wave function, all of it, a kind of argument, laid out in the language of mathematics across billions of light years of space-time. And then it produced, here, exactly once, as far as we know, a reader. You are the reader. Not metaphorically, not poetically. You, Specifically, with the brain that formed in the specific conditions of this planet, capable of the specific abstract reasoning that lets you follow an equation across billions of light years to a conclusion about the shape of space-time. You will never directly experience. You are the universe's proof, becoming aware of itself. Whether mathematics exists independently or whether we built the language to describe something that was always real, either answer arrives at the same place. The geometry was running. We started reading it, and the reading changed something, because now the universe contains not just the pattern but the knowledge of the pattern. Not just the spiral but the mind that sees it as a spiral and asks what it means. Carl Sagan said we are a way for the cosmos to know itself. He meant it. He was not being poetic in the soft sense. He was pointing at something structural. 1. The universe produced conditions that produced chemistry, that produced biology, that produced nervous systems, that produced abstract reasoning, that produced mathematics, that produced the capacity to describe the universe. It is a loop. A closed one. And there is something in the geometry of that loop, a shape it makes when you step back far enough to see the whole arc, that feels less like accident and more like something the universe was always doing, slowly, across all that time and silence and darkness. Waiting. Not for us specifically. Not with intention. But waiting the way. A proof waits for someone to follow the steps all the way to the end. We followed them. We are still following them. And no one knows what the last line says.